Okay, the next data structure is queue data structure, and it is a linear data structure, and it uses FIFO principle for applying the operations, that is in, first out principle. So the two operations, just like a stack, it uses two operations, enqueue and dequeue. So the two operations are enqueue and dequeue. So enqueue operation is used for inserting an item into the stack, and dequeue is representing an operation of removing an item from the queue. So enqueue is used for inserting an item into the queue, and dequeue is for removing an item from the queue. So here, how we can visualize this data structure is we can consider it as a container that is horizontally oriented and having an opening from both sides, from the rear side and from the front side. So from the front side, it is having an opening and another from the rear side. So here the two operations are performed in a regular queue. The two operations are applied from the opposite sides. That is, the enqueue operation is done only from the rear side, and the removal of an item, that is dequeue operation, is performed from the front. This container is having two openings, from the rear side, from the back side, and from the front side. The back side we call it rear side, and the front side. So the front side is used for removing an item from the queue, and the rear side or the back side is used for inserting an item into the queue. So for example, if we have those set of operations to be applied on the queue, here in queue B, this will add B into the first slot. Then again in queue C, then it will add B into the next slot, that is B then C. So the B is at the front and C at the back side. DQ will remove B because the front is B, and will be left with, the container will be left with only C after DQ operation. Then in queue G, so from the rear side we should add G, so the front is now C. Then in queue F, we should add F from the rear side, so the front is C, then middle one is G. DQ operation will remove from the front, so it will remove C, and the container will be left with G and F. And in queue A operation, this will add A from the rear side, so the front is now G, and the rear side, from the rear side, the element A will be added at the back. DQ operation will remove G because G is the front. So the container will be left with F and A. So now this step, F is the front and A is at the rear side, of the queue. So in this way, queue can be implemented. So the two operations, just similar to stack, we can also implement queue as an array. So the array implementation of the two operations of queue, the enqueue and dequeue. So the two operations can be implemented. So here, when we are implementing the two operations using array, always we should think of the maximum size, because arrays are having the maximum size, the maximum limit. That's why. So here we should think of the maximum size. So here we are considering the variable num, as the QE. That's the QE having the maximum size. So we need to use two indexes. So the integer variables of integer type, we use index. So the front index and the rear index. So the front index and rear index should be used to index or to access the elements from the front for during the removal, and to access the slots for adding the elements into the QE during the enqueue operation. So initially we should just set the front and rear as -1, just to let the QE to indicate that the QE is empty initially. And the QE size here, the QE size is not the maximum size, but to indicate the number of elements. So here the QE size is indicating the number of elements in the QE, the number of elements in there. So initially we can just let it be initialized with 0. So for the enqueue operation, we should check if there is a space in the QE, because as we are implementing the QE using the array, so the maximum size is a concern. So we should just check whether it is the rear is less than the maximum size -1, the maximum size -1, because here we are using the rear to insert an element into the QE. So using rear as an index, so we need to compare that value, this value with the maximum size -1. So if it is yes, so we should increment the rear and store the item or the data into the num of rear, because here we are using the rear as an index. And then increment the QE size, because this QE size is a variable indicating the number of elements, in the elements in QE. So we should increment that QE size. Then front is equal to -1. We should check if still front is equal to -1. That is it still indicating that the QE is empty? If not, then we should do nothing. But if this condition is true, since we added an element into the QE, we should increment the front to indicate that the QE is having an element. So this front will point the front element to be removed. So it should point to the front element, that can be removed by the dequeue operation. If this condition is false, then the QE is overflow during the enqueue operation. If the rear is not less than the maximum size -1, that means the QE is already in queue overflow state. Because every time we are applying the enqueue operation, we are incrementing the rear. That's why we at some point we may reach at the condition where rear is greater than, or the rear is greater than or equal to maximum size -1. So the next operation is dequeue operation, and this is an operation to remove data from the queue. So we should check if there is data in the queue. So if this, to check whether it is whether there is data in the queue, we can just simply check whether queue size is greater than 0, because we said that this queue size is indicating the number of elements. So this queue size is greater than 0. If this condition is true, then we can copy the value pointed by the front variable, because here the front variable is used to indicate an element that can be removed. So front is used as an index, and it is changed here during the enqueue operation. It is just incremented or adjusted its position. So whenever data is there inside the queue, the front variable will be pointing to the element that is the one in the front position of the queue. So we should copy that front element to a given variable that will be returned to the caller function, and then increment the front. So now we should change the front variable location to the new location, shifting from the slot from which we removed an element to the another next element, next slot. So the next one is decrementing the size. Why we are decrementing the queue size is because we removed an element, so the queue size should be removed by 1. It should be decremented. To indicate that the number of elements is reduced by 1 because of the application of this dequeue operation. And if this condition is false, then the queue is in underflow state. That means there is no any number. That is, the queue size is equal to 0 means there is no any number that can be removed from the queue. So the enqueue operation, the two operations can be simply implemented like this. So initially the maximum size of the queue, as we are implementing it using an array, we should set the maximum size. We initially set it as 100. We can just specify any size depending on the memory capacity of our computer. We can just set any maximum size. The rear initially and the front initially -1. Though both variables are initially set as -1, and those are the ones used for indexing the array, which is used as a queue for the implementation. So the queue size is initially 0 because there is no any element in the queue. And so the enqueue operation takes as a parameter the element to be inserted into the queue. So if the rear is less than the max size -1, so this is a condition that we should check first. So if the rear is max size -1, less than max size -1, we should increment the rear, and then name of rear is equal to x, because we just set the slot by the rear variable after incrementation, then place the new element to be added into the queue into that slot, and incrementing the queue size because the number of elements of the queue will be maximized, so the queue size should be incremented. And if the front is equal to -1, we should increment it. That is, if the front is still indicating that the queue is empty, we should change it because we have already added an element here. So after the addition of the element in the queue, we should check whether the pointer, the variable front is still indicating that the queue is empty or not. So if it is the case, we should increment the front. If not, then we simply go out of the enqueue operation. If this condition is false, then we should report the queue is overflow. That is, the queue is full. That is, it reached its maximum size. And the dequeue operation, can be implemented by just declaring a variable x that will hold the number that will be holding a number removed from the queue. So to remove an element from the queue, first we should check whether there is any element in the queue. So to do that, we should check the queue size, if it is greater than 0 or not. If it is greater than 0, that means there is an element that can be removed. So assigning the element that is pointed by the front variable on x, then incrementing the front, then queue size is reduced. So here, in the case of dequeue, the queue size is decremented. In the case of enqueue, the queue size is incremented. So here, the front is incremented. The front is incremented here because the element that is first pointed by the front variable is already removed, so we should change the slot pointed by the front to the another slot that is next to the previously pointed slot. So otherwise, if this condition is false, then we can report queue underflow. That is, there is no any element to be removed from the queue. So we can also implement the queue using circular array. So the enqueue operations. The enqueue operations can be implemented on using the circular array, the enqueue and dequeue operations. So circular array, from the regular array, we can use the circular array. So what makes this circular array different from regular array is that in the case when we just remove an element from a given slot, in the case of regular array, there is no way of reusing any empty slot from which we previously removed an element. But in the case of circular array, we can use indexes. That can circulating over the slots of the array, and if there is any slot even from which we previously removed an item, if there is any slot which is left empty because of the removal of an item, we can reuse that empty slot. So in the case of circular array, the overflow will be happen if and only if all slots are filled by the numbers or the elements. So if all elements slots are filled by elements, the queue will report overflow. If any slot which is left empty because of the removal of an element from that particular space, the slot will be reused in the case of circular array. That is what we are looking here for this particular example. For the simple array, let's say we have 4 slots, and for the circular array we have 4 slots. So in queue of B, for example, here it will in queue B, and for the circular array B, and in queue C C will be added. The Q size is 2, the Q size is 2 here. Then DQ, it will remove B, it will remove B equal. Then in Q G, so G will be added, G will be added, and Q size is 2. In Q F, in Q F, so F will be added, the Q size is 3. DQ, so it will remove C, it will remove C here. In Q A, in Q A here. Here, in the case of simple array, it starts reporting overflow because we have already used all slots. Although we have removed two elements from or although we have two slots, empty slots from which we removed an items, still it is reporting overflow. But in the case of circular array, it is circulating and again reusing any empty slot. But here when we include D again, it becomes full. So at this step it becomes overflow. So for this one, the overflow is started once we touched each step once. I mean each slot once. But in the case of circular array, if there is any slot which is empty, either because of the removal of an item from the slot, or because it is not assigned any value yet, we can use that slot. We can possibly use that slot. So in the case of circular array, overflow will happen only if all slots are filled with an element or filled with a value. And in the case of simple array, the overflow will soon happen as we touched the element, slots each slot during the enqueue operation. So in order to just address the problem associated with the simple arrays or the regular arrays, we can use circular arrays. So we can implement the circular array so that you can just rotate the front and the rear to be rotated. So you can just see those implementations of the enqueue and dequeue operation on the circular array. So the implementation of dequeue operation, you can just from this one. For the implementation of queue using the linked list, you can again use, just similar to the stack, you can use single linked list, and the enqueue operation can be considered as the operation of inserting a node at the end of single linked list, and dequeue is considered as deleting a node from the first position of the linked list. So here you are just expected to write the enqueue and dequeue operations because they are very simple. So let you take this one as an exercise. So just use this one as an exercise and write the enqueue and dequeue operations. Just writing the enqueue operation as an operation of adding a node at the end of a single linked list and removing a node from the first is dequeue operation. So just let you write the code for each of those operations. So another type of queue is deque. We call it deque, and it is another variant of queue data structure which is having the two openings as the regular Q data structure, but what makes it different from the regular Q data structure is that it is possible, in this case in DEC, it is possible to apply both operations, the DQ operation and the INQ operation from the both sides. So from the rear side, it is possible to INQ as well as DQ an element. And it is also possible to INQ from the front and DQ from the front. So 4 possible operations can be applied on DEC. So the insertion and deletion operations can occur at the right end, at the either of the ends. So at either end we can apply DQ and INQ. So just this, the implementation of this Q data structure is similar to that of the regular Q data structure, and this is implemented using doubly linked list. So when you are using doubly linked list for the implementation of this DEC, so what you should consider is you should independently implement those 4 operations. So INQ front will remove an element, will add an element from the front, adding a node at the start, and DQ front is removing an element from the start. INQ adding an element at the end, and DQ removing an element from the end. So just simple operations you can implement. The other type is priority queue. So here this is also another variant of queue data structure in which elements inside the queue are associated a key during the insertion operation. Each data item will be assigned a key that can indicate the priority level of the element. So the operations that will be applied on the elements of the queue will be performed based on the priority level. That's why the queue is considered as the priority queue. So the DQ and the INQ operations has to be modified because the priority level will be considered when those operations will be applied on the elements of the queue. For example, if we have a queue of persons, like the females having the higher priority than males, that is, the gender is the key. Gender is a key attribute that is indicating the priority level. So if females are having the highest priority than males, so assuming that the priority queue is filled like this, during the insertion the priority queue is filled like this. So above the first element, the second, the third, and fourth. So those are the persons filled inside the priority queue. So when DQ operation is applied, as females are having the highest priority, so this is above is at the front, and the Jonas is from at the rear side. So from the front side, when DQ operation is applied, it first checks whether Abebe is having the highest priority. It is male, no. Alemu, male, no. Aster, female, yes. This is the one having the highest priority. So this will be removed. So the priority queue will be left with Abebe, Alemu, Belai, Kadir, Meron, Jonas. So the remaining items will be left. Then again DQ, again another DQ operation. So it will just look for the first female. So the first female is Meron. So it will remove Meron from the list, and the remaining is this one. So now the queue has data having equal priority, and the dequeue operation deletes the front element like the case of the ordinary queues. So Abebe will be removed first, then Alemu will be removed, because all elements are having the same priority level. So the operation of the dequeue should be modified. Its implementation should be modified. Another concept related to queue is the demerging and merging of queues. So demerging is just a process of creating two or more queues from single queue. So based on the priority level. So if we have a priority queue, we can demerge, or we can divide one queue into two or more based on the priority categories. So for example, the previous queue can be categorized into two because we have gender as a priority indicator key attribute. So here we can categorize the female as another queue and the male set as another queue. So this is we can how we can create sub queues from single priority queue. So for creating such sub queues, we should consider the priority level though. So until the priority queue is becoming empty, we just create just sub queues. So based on the number of priority categories. So for our case, since we have a priority having the two categories, we can create two empty queues. So then removing an element from the priority queue, then checking it is a priority type. So dequeue priority queue, the original priority queue, then the removed data will be checked. If the gender of the removed data is female, then we should add into the female queue, and we should enqueue into the female queue. If it is the male, then S part we should enqueue into the male queue. So this demerging process is performed by removing an item from the priority queue, then enqueuing into the appropriate queue based on the priority category. So demerging process is simply a process of creating two or more queues from a single queue. And merging process is an opposite of demerging. So merging queue is just a process of creating a single queue, priority queue from the given sub queues. From the given sub queues, we can create single priority queue. So the ordinary dequeue implementation can be used to delete data in newly created priority queue. So we should just remove an element. We just create a single priority queue, then remove an item from each of the queues. So from the male, we can remove an item and add into the priority queue. Then from the females, we can remove. So female removed, then added to the priority queue. Then next is Meron, removed from the female queue and added into the priority queue. Then we remove Abebe, then add, then Alemu, then Belai, then Kader, then Jonas. So we can just add the items from the sub queues. Remove items from the sub queues and creating the priority queue, single priority queue based on their priority level. So this merging process is just simply the removal of an item from the sub queues and creating the single priority queue from the sub queues. So we can have such different variants of queues. So finally, we can have some application areas where this concept, the QE concept, can be used. So for print server, the print server, just internally using the QE data structure for printing any document. So the printing service or printing a document is based on their arrival time. So any document that is the first arrival will be first printed. So internally it uses the first in first out principle, the queue principle, for printing documents. The disk drivers are also internally using the queue data structure internally. So for the input output requests, it depends on their arrival time. So internally maintaining the queue data structure, the task schedulers in operating system, multi-processing systems internally for execution of processes. It is using the priority queue type, and telephone calls in the busy environment. In a given busy environment, it's also making the use of queuing, telephone calls. Then simulation of waiting line maintenance, the queue of persons. So such machines or such scenarios or environments they are using the QE concept. That's all. Thank you.